Hello, my name is Steev Goodwin from Team Similarly Geeky, and this is our project Emotiscan using Stolid. It uses vCons to pinpoint specific customer complaints and adds a touch of SCITT to verify that analysis really does come from me. So when I first looked at this problem, it seemed like a simple big data issue. Throw everything into Elasticsearch and be in the pub before lunchtime. But then I realized the domain. Customer calls. Don't need it. A conversation between a customer and a business agent is linear, or at least it should be. A customer calls up feeling angry or upset, and by the end of the call, the agent has convinced them that everything's all right, and they can go home happy. So I reduced this problem to one of sentiment analysis. By categorizing the customer's sentiment at each point of the call along the time axis, I can highlight issues in the conversation that need to be addressed by future agents, whenever this doesn't go in the way you expect. And this reduces a big, long conversation vCon into a list of maybe 20 numbers, much like a normal conversation. I don't need to understand the Japanese phrase for, "I'm so sorry there are no reservations today." After the waiter has said, "Yeah," and started to shake their head, I already know what's going on. So taking the example, faked vCon datasets, I wrote up an analysis program, ran the vCons through and produced an executive summary. Each summary entry includes the conversations that had gone downhill the whole way, conversations that went good, then bad, then good, then bad, showing that the agent probably isn't having an effect on the customer. But I also reasoned that the conversation where everything was always going well showed us the sort of target and KPIs that we should be aiming for. Each one of these is output with the UUID of the call, the agent's name, before and after text to show how the customer's sentiment changed in response to what the agent said, the numbers from the sentiment analysis code, which provides some feedback so we can generate a better sentiment AI model next time round, and the JSON path, which allows us to point directly into the vCon for the area under question. Now this seemed to work fairly well, and in writing the code though, a few things did trip me up. Initially I didn't understand why the vCon analysis field is an array. I felt it should be an object. It meant I had to iterate the array just to find the ones with the right type. Also, I was working in Node, and all the examples were in Python, since I understand Node a bit better. So I ended up writing a Node library with vCon while I was at it. The JSON also has an analysis body entry, which refers to speaker, while other sections of the same document refer to parties. I also noticed there were no timestamps in the body of the conversation, but unlike last year's redacted vCons, which had them, this didn't. And that's not surprising because it's AI generated, and AI doesn't consider how speech is paced. And it was this AI generatedness that made me wonder, how accurate is my approach? Several of the conversations I read manually always seemed to be very positive interactions. They always went up, they always had a good ending. They were also very short conversations, which meant that there were very few exchanges between the two parties where meaningful data points could be derived. Plus, secondly, I wanted to run some correlation software, something fancy like Granger, Pearson, or Spearman, for example. But the AI generation process is stateless. So if AI generates a fake name of Ryan Henderson twice, there's no consistent personality for Ryan. So I couldn't correlate fake Ryan to fake ability. And that means that the cause and effect of the agent on the customer is lost. So to continue, I actually needed some longer vCons to solve both of these problems. So I generated some. Unfortunately, as I said, I was using Node, and the ChatGPT prompts were present in the JSON file. They produced illegal JSON, at least as far as Node goes, and here's the result of one. It shows promise, but with room for improvement. For example, when an agent asks, "Is that everything?" and the customer goes, "No, I think that covers everything. Thank you very much, Ryan." You get a negative sentiment from the word no. And this causes a little dip at the end and it overrides everything else that's being said. So from here, I have my own analysis code of the conversation, and I upload this analysis to data trails. This is stored as a SCITT response in a file locally. And there we have it, an analysis of over 100 vCon chats to find those agents that need to improve and why. The analysis is stored in data trails and then certified with SCITT to show that it really did come from my code. And this is all tagged with the implementation version number, the UUID of the original call, should anything need to be amended or appended in the future. And of course, there's some ASCII command line graphs just to show off. So that is all from me. Bye for now.